Hello friends, welcome to the first part of our mathematics program on sets. In our grade 7 programs on set, we learned how to distinguish among different types of sets, identify and use set notations, find the cardinal number of a given set, find union and intersection of two sets, identify and use complement of a set, represent two sets on a Venn diagram, shade required region or regions on a Venn diagram. Today, we are going to learn how to use Venn diagrams and operation on set and how to solve survey problems involving two sets only. So let's begin. Let's start with an activity. During a health awareness week at school, Mrs. Rina, the mathematics teacher, conducted a survey among her 20 students on whether they would prefer to go jogging or for a walk every morning. She defined her sets as follows. The universal set represents the 20 students being surveyed. The set J represents students who prefer jogging, and the set W represents students who prefer to go for a walk. She then represented the information on two Venn diagrams as shown on the following slide. The first Venn diagram represents the elements in each region. That is, we can see that in the set J, we have Ram, Zain, Bilal, Tia, Velen, Fina, Aidan, Kate, Yohan, Sami, and Devina. In the set W, we have Anya, Nora, Hina, Momoy, Charlie, Pooja, Gail. Yohan, Sami, and Devina are repeated again in the set W. Also, we have two students outside the sets who are Lalita and Elias. Whereas the second Venn diagram represents the number of elements in each region, that is, instead of writing the elements, we have counted the number of elements and wrote the cardinal number in each region. We can see that there are 8 students who like jogging only, 3 students in the intersection part, 7 students like walking only, and there are 2 students who like neither. Which representation is simpler, easier to understand? For what reasons? From the previous activity, it is clear that representing the number of elements instead of the elements themselves on a Venn diagram is more appropriate and easier to understand. It takes less time, there is less risk of making mistakes. It is easier to analyze the information. Let's have a look at real-life problems. Businesses and authorities often carry out surveys to collect useful information for profit-making or future decision-making. Venn diagrams can be used to solve survey problems in real life. It is more appropriate to use the cardinal numbers of the different sets when dealing with large data. Let's have a look at example 1. 64 students present in a school canteen were interviewed on whether they would like to have yogurt or ice cream for dessert on a particular day. These results can be displayed on a Venn diagram. The sets involved are as follows. The universal set represents the 64 students being surveyed. The set Y represents the student who like yogurt, and the set I represents the students who like ice cream. This is the Venn diagram that was obtained after the survey. The rectangle is representing the universal set. There are two intersecting circles. The circle on the left-hand side is representing the set Y, and it contains two cardinal numbers, 32 and 10, whereas the other circle is representing the set I, and it contains two cardinal numbers, 10 and 18. We can also see that there is a cardinal number 4 outside the two circles. Using the Venn diagram, let's answer the following questions. How many students like yogurt, like both yogurt and ice cream, like ice cream only, like neither yogurt nor ice cream? Let's write down the information given to us and define the sets. There are two sets involved. The set Y represents students who like yogurt. The set I represents students who like ice cream. The universal set represents the 64 students being surveyed. Part A. We have to find the number of students who like yogurt. From the Venn diagram, we see that the set Y contains two cardinal numbers, that is 32 and 10. These cardinal numbers inside the set Y represents the number of students who like yogurt. Therefore, the number of elements in the set Y is 32 plus 10, which is equal to 42. Part B. The number of students who like both yogurt and ice cream. Here, we are looking for the intersection between the two sets. From the Venn diagram, we can see that there are 10 elements that lie in the intersection region, that is, 10 students who like both. The number of elements in the set Y intersection I, please note that the symbol N between the letter I and Y represent intersection. So let's read it again. The number of elements in the set Y intersection I is 10. So let's read it again. The number of elements in the set Y intersection I is 10. Part C. Number of students who like ice cream. From the Venn diagram, we see that there are two cardinal numbers inside the set I, that is 10 and 18. Therefore, the number of elements in the set I is 10 plus 18, which is equal to 28. Part D. Number of students who like ice cream only. Here, we are looking for the common student who don't like yogurt but like ice cream. This set can be written as the complement of set Y, written as Y dash, intersection with the set I. Before we move on, let's have a quick recap on complement of a set. It is those elements that lie outside the set or does not belong to the set. If we are looking at the Venn diagram, there are two cardinal numbers that are outside the set Y, that is 18 and 4. The set I contains two cardinal numbers 10 and 18. The intersection between the two sets is 18. That is, there are only 18 students who like ice cream only. Similarly, we can proceed in the same way. We will see that there are 32 students who like yogurt only. Part E. Here we are looking for the number of elements of the complement of the set Y union I. Here we are looking for those elements that do not belong to the sets Y union I. That is, the number of elements in the set Y union I dash. Note that the symbol U between the letters Y and I represent union of the sets. First, let's have a look what lies inside the set Y union I. From the Venn diagram, we see that there are 3 cardinal numbers inside the sets Y and I, that is 32, 10 and 18. Therefore, what lies outside? From the Venn diagram, we see that there are 4 students outside the sets. This represents the number of students who neither like yogurt nor ice cream. So the answer is 4. Let's have a look again at our Venn diagram. Each cardinal number represents the number of elements in a particular region. The number of elements in the universal set is 64. There are 32 students who like yogurt only. That is, the number of elements in the set Y intersection I dash is 32. 10 students like both yogurt and ice cream. That is, the number of elements in the set Y intersection I is 10. 18 students like ice cream only. The number of elements in the set Y dash intersection I is 18. And there are 4 students who like neither yogurt nor ice cream. That is, the number of elements in the set Y union I dash is 4. 60 students like either yogurt or ice cream or both. That is, the number of elements in the set Y union I is 32 plus 10 plus 18, which is equal to 60. Let's have a look at example 2. Every morning, the office workers at Chung & Sons Company Limited have a tea break. The workers present on one particular morning were interviewed on whether they would like to have their tea with milk or sugar. Let's write down the information given to us and define the sets. First, the results are displayed in the Venn diagram. The set M represents workers who like milk. The set S represents workers who like sugar. Find the number of workers who added milk to their tea. Part B. Find the number of workers present on that particular morning. Part A. Number of workers who added milk to their tea. All workers inside the set M, that is, all the elements that belong to the set M. From the Venn diagram, we see that the cardinal numbers 36 and 27 are inside the set M. We add them up to get 63. The number of elements in the set M is 63. Part B. Number of workers present on that particular morning. That is, we add all the elements inside the two circles, including 5 outside the circles, which gives us the number of elements in the universal set is 36 plus 27 plus 12 plus 5, which give us 80. Now that we have done a few examples for you, here are some exercises for you to practice. Now that you have done the exercises, you can also visit these interesting links to facilitate the understanding of the concepts. So friends, we have seen together how to use Venn diagrams and operations on sets to solve survey problems involving two sets only. We have also worked a few examples for you. So now you can try to practice the exercises on your own, with your friends at school, or even with the help of your teacher. It's time to leave you now. Until next time, it's goodbye, friends.